Imagine waking up to a morning where the sun is no longer the most powerful force in our neighborhood. An invisible intruder, massing 10 times our sun, has just crossed the threshold of our solar system, a stellar mass black hole. What if this wasn't science fiction, but our reality tomorrow? How would we know? And could we survive? Today, we explore the physics of a cosmic catastrophe. If you're fascinated by the mysteries of space, subscribe for more deep dives into the unknown. To understand the threat, we must understand the beast. Stellar mass black holes are the remnants of collapsed giants. They are compact, invisible, and possess a gravitational grip that nothing, not even light, can escape. Because they emit no light, finding a rogue black hole is one of the greatest challenges in modern astronomy. We look for microlensing, the way a black hole's gravity acts like a magnifying glass, warping the light of distant stars. Even the subtle wobble of Mars's orbit, measured down to centimeters, could betray an intruder's presence long before it arrives. But by the time we see the signs, it might already be too late. The first point of contact is the Oort cloud. 2,000 astronomical units out, the Oort cloud marks the gravitational border of our solar system. As the black hole tears through this icy graveyard, it triggers a gravitational cascade. Millions of comets are hurled toward the sun. For Earth, this means a bombardment of icy giants, a storm of comets that could last for thousands of years. Our first visual confirmation might be the accretion flares, death screams of matter being shredded by tidal forces. Future tech, like the Vera Rubin Observatory, is designed to catch these brief, violent signatures in the dark. As the intruder reaches the inner solar system, the real chaos begins. Jupiter, our planetary shield, is in trouble. Jupiter's orbit is warped, shifting the gravitational balance of every other planet in the system. Even a distant pass could nudge Earth out of the habitable zone. A shift of just a few percent would end the world as we know it. Liquid water would become impossible. Earth would become a wandering ice ball, drifting in the shadow of the black hole. If you're enjoying this deep dive, hit that like button and tell us, which planet do you think survives longest? But what if it gets closer? A pass between Earth and Mars would unleash unimaginable tidal forces. Tidal heating would melt the crust. Earth would be transformed into a world of magma and fire. Our atmosphere would be stripped away, leaving a scorched, airless rock behind. Life would be extinguished in an instant. In the chaos, planets could be ejected entirely, hurled into the interstellar void to wander as rogue worlds forever. The black hole might even capture the sun, creating a bizarre binary system of light and absolute darkness. Or, in the most extreme case, the sun itself could be consumed. A stellar feast that leaves the solar system in total darkness. At the event horizon, physics breaks. Time stops. Everything we are and everything we were vanishes. Could humanity survive? Perhaps on rogue planets powered by geothermal heat, or deep within subterranean cities. We might become the intruders ourselves, fleeing our dying system in search of a new home among the stars. The good news? Space is incredibly empty. The chances of a rogue black hole finding us are almost zero. But studying these invisible giants reminds us of how fragile and how precious our oasis in the dark really is. If you found this journey inspiring, like, share, and subscribe to join us for our next cosmic exploration. Stay curious.